Today we are going to begin Unit 2, Lesson 1 for our Math 1 course. This one lesson today is going to be review of 3 different lessons that we did in Foundations last semester. So if you go back to our video lessons from Foundations, find Unit 4 and video lessons 1, 2, and 3, we'll break down today's lesson a little more slowly for you. All right? Today is just a very condensed, very abbreviated version of what we've already learned. Plus, I'm going to add on one small piece at the very end. If you look at examples 5 and 6 on the bottom right-hand side of today's paper. Okay, so a relation. A relation can be represented as an equation, as a set of ordered pairs, as a table, and as a graph. The only thing that we're going to be missing today from our examples is, at least in the first part, is the equation. We're not going to look at it as an equation quite yet. We'll do that on the other half of our paper. We will, however, have to identify the domain. If you remember, those are our x values, or they are our input values. So I'm going to use green today to represent my domain. My range is going to be my y values. The y values are the output values on a table. In the ordered pairs, they are the second number. So I'm underlining the correct domain and range values down below. That's really where we're going to begin. The last thing that we'll need to do today is to determine if our relation that we have is a function or not. Remember, there is one way to be a function. Each input value can only be matched with one output value. If that is not happening, then we do not have a function. And one easy way that we can tell if a relation is a function is if we graph those values by plotting the points on the coordinate plane and then try to use the vertical line test. If you draw a vertical line through every point in your relation, that vertical line should only touch one point. If it does not only touch one point, then it is not a function. So we're going to look at all that right here in example 1, which I underlined as we were talking about our domain and range. So my domain values are green. I do see a 2, a -1, a 0, and a 4. When we put these in the table, we can put them in the exact same order that they give them to me on in the ordered pairs, okay? So 2, -1, 0, and 4. Now, when I write the domain out as a list over here, remember to use your braces. And when you put them in the braces, you need to put the numbers in numerical order. So starting with the smallest number, -1 is the smallest, then 0, and then 2, and then 4. Now, if there was a repeat, say there was another ordered pair that had an x value with a 4, we would not put a repeat. We only write those numbers one time. Now let's move over to our range. I underlined those in red, and I'm going to match those up in the table in the same order. See how in the ordered pair, the very first one here, 2 is paired up with 1. So when I put those in the table, I need to put the 2 and the 1 beside each other. -1 and -5 go together, 0 and -3, and then the 4 and the 2. So those range values are my output values. And now I'm going to make my list in my braces. And let's put those in numerical order. So the smallest number here is -5, -3, 1, and 2. And there are no repeats. My next step is to plot the ordered pairs on the coordinate plane. So if I'm going to label these, I told you that we could see them as a set of ordered pairs. That's what this is, ordered pairs. We could see them as a table, and this is the table. We could see them as a graph, and this is the graph. And then we could also look at them as an equation, which we will get to later in this lesson, but we just won't see it in these first few examples, okay? So let's plot these. I'm going to go, remember, when we're plotting the points, the x value comes first. So we go on the x-axis first, over 2, up 1, and we put a point. Next is -1, down 5, and then we put a point. 0, -3, we put a point, and then over 4, to the right 4, and then +2, and we put a point. So now that we have graphed all of our ordered pairs, now we can determine, is this a function or not? So I'm going to use blue when I do my vertical line test or when I'm determining if something is a function or not. All right. So what you can do, vertical lines go up and down. So draw a vertical line through every single one of your ordered pairs. And then the question that you ask yourself is, does any one of those blue lines hit more than 1 point? And they don't. They only hit 1 point, which is exactly what we want for that to be a function. Great job. So now let's look at example number 2. Remember, sometimes they will not always start out by giving you the ordered pairs. Sometimes they might give you the values in the table, or they might even give you the graph first. And then we have to use whatever they give us to extract the information. So for instance, if I had this on my graph, I could say that the ordered pair here is +3, -3. And I'd have to get the list of ordered pairs by looking at where the points are plotted. All right. Just wanted you to know what to do if you saw the graph first. In this case, we're looking at the table first. So in this example, they started out by giving me the table first instead of the graph. So let's look at this table and we are going to pull out the domain values. Remember, I'm using green for the domain, and the domain is the x values. So I'm going to list them in order from smallest to biggest. So I see a -3. I'm going to check it as I use it. I see a -3, but that's a repeat, so I don't want to put it again. Okay. Next, I have a 0. That's the next biggest number. Then a 1 is the next biggest number. And then a +3. All right, and then wrap it up into your braces. So I have found my range or my domain. All right, so now we're going to go ahead and find the range. Remember, I'm using red for the range, and the range is going to be my y values. So again, we're going to wrap these up in braces, and I'm going to start with the smallest value. So -5 is the smallest. Next, I see a -2. And then a +2, and then a 3, and then a 4. Okay, so that is my range. Those are in numerical order. Now I'm going to erase all my little check marks. Here's what I'm going to do for my ordered pairs. I have 1, 2, 3, 4, 5. I have 5 ordered pairs that will be in my braces. And I'm still going to use green for my x values, but I'm going to put them in the exact same order I see them in the table. So -3, 0, 3, -3, and 1. And now I'm going to put my range in the same order I see them in the table. So +3, +4, -5, 2, and -2. The only time that we do not put repeats is when we are listing them out in the braces. And I'm just going to go back and add my commas. Okay. So great. We identified the list of ordered pairs. We identified the values that are in the domain and the values that are in the range. And now it's time to go ahead and fill in my graph. So over here, we did the ordered pairs. All right. So let's plot these points. -3, +3, 0, 4, 3, -5, -3 to the left, +2, and then +1, -2. right here. I'm now ready to determine if this is a function using my vertical line test. So draw a vertical line through every single one of these ordered pairs. And on any of those vertical lines, do you see more than one ordered pair plotted? And the answer is yes, right here. Okay, there's 2 points on this vertical line. So that means no. No, this is not a function because it failed the vertical line test. Now, I want to remind you, though, how you can also check from a table or from the ordered pairs. So if we look at where we have a repeat, the -3 and the -3, if you ever see a repeat in the x variables, then you want to look at the y variables next to them. I see a 2 and I see the 3, and this 2 and this 3 are not the same. And so that is another way that you could see if the x values match but the y values do not. That is also not a function. Good job. We're going to kind of switch modes now, and we're going to do a brief review of what is function notation. So for function notation, you're going to see f parentheses x and then close the parentheses. The way that you actually read that is f of x. And what that means is that we have a function. The name of the function is f. You might also see a g of x. The name of that function would be g. Another common one is h of x. You could really see any letter, but I think f, g, and h are the 3 most common, and you're definitely going to see that more in Math 2 and in Math 3. But we typically use f in Math 1, but sometimes you will see a g function. That's just the name of the function. And then the function has an input value of x. So here's what that means. That means that actually is a number. And if you look back here, what is the number that replaced the x? And in this case, it was a 3. So what you're going to do is you're going to replace everywhere you see an x, you're going to replace it with the number 3. So f of 3, actually I want to write that in blue. F of 3 equals 2. And then I'm going to use parentheses, okay? So f of, instead of x, I put a 3, equals 2, and then instead of x, I put a 3, minus 3. And now what I simply need to do is to simplify this using my order of operations. And if you need some assistance on remembering what that is, it's parentheses, exponents, multiplication and division from left to right, and then addition and subtraction from left to right. Okay, some people remember PEMDAS, some people remember Please Excuse My Dear Aunt Sally. So what I'm going to simply do now is simplify this. So there's nothing I can do with the f of 3, so I'm just going to keep having to bring it down. I see no parentheses. Remember, when it's just a single number inside a parenthesis, it doesn't represent a real parenthesis where you can do something to it. It represents multiplication. I don't see any exponents. I do see multiplication. 2 times 3 is 6. Bring down the minus 3. Okay. Bring this down to keep it nice and neat. And now I see some subtraction. So from left to right, 6 minus 3 is 3. And that's my final answer. F of 3 equals 3. I'd like for you to, well, let's just do it together because I see the fraction and I know that you guys get very uncomfortable with the fractions. So what we're going to do is we're going to take this x value, and this f of x is 16, and we're going to replace the x with 16. So let's go ahead and do our f of parenthesis 7 over 8 parenthesis plus 4. So I went ahead and I rewrote that, and now I'm going to do my substitution. Instead of x, I'm going to have a 16. All right, and now we're ready to simplify. So f of 16 equals, I do see some multiplication here. I have 7/8 times 16. If it helps you to put that over 1, you can. 16 over 8 is just a 2. And then 7 times 2 is 14. And then bring down the plus 4. And then f of 16 equals 14 plus 4 is 18. And that's my answer. Now I want to add just one small note here at the bottom that you can put the input and output values and create a table using this method. So if they gave you, say in example 3 here, it said find f of 3, find f of 5, find f of 7. And you would take all those values, the inputs, and then put the outputs in a table next to it. And you could use this to create a table of values. So in example 3, my input value is 3. That was my x. And then my output value is also 3. Remember, your output is your y value. In example 4, my input value, my x value is a 16, and my output value was an 18. And again, if you had more input values and more output values, then you would have more information to put into your table. And you could even use that to go ahead and graph. All right. Now let's move on over to the second side of this paper. Linear equations as functions. So we're still working with domain and range over here. Given the function y equals 3x plus 2, and the domain is -1, 1, and 3, find the range. So here's how we do this. They want us to find 3 separate input values, and then a list of the 3 output values that go with them. So I do want you to know that y equals and f of x equals are different representations of the same thing. They both just mean y. So when you see y equals 3x plus 2 and they want you to find the range, then you're still simply just going to plug in. And so this is still going to be your list, because it's your domain, your x values. So I'm kind of going to break this problem up into 3 different parts. And then at the very end here, I'll know what my range is. And that'll be my answer. So instead of y equals 3x, I'm going to put y equals 3 parentheses plus 2 everywhere. And remember, what I'm going to plug in are the -1, the +1, and the +3. And once those are put in there, now I'm ready to simplify. And I'm just doing simple multiplication, and then I'm adding. So 3 times 3 is 9, and then 9 plus 2 is 11. So here are my range values. All right, I have -1, positive 5, positive 11. That's my range. And that's all there is to it. Now, what if they give you the range right here? These are y values. They give you the range and they want you to find the domain. And I'm sorry, I should have used green up here because I've been using green to represent my domain. Okay, so these are my x's are green. So same process. This is going to kind of be 3 different problems. But instead of replacing the x value, I am now going to be replacing the y value. So I have a -2, I have a 0, and I have a 3. And then I'm going to fill in the rest of the equation. So let's fill in the rest of the equation. -x plus 4 equals -x plus 4 equals -x plus 4. And let's go ahead and simplify all of these. Subtract 4 to get the x by itself. Gives me -6 equals -x. And then remember, you would divide by -1. Divide by -1. So 6 equals x. Let's do it again. Subtract 4. 0 minus 4 is -4. Divide by -1 on both sides to get that x by itself. And I have 4 equals x. And then one more time, subtract 4. 3 minus 4 is -1. And then get the x by itself. So divide by -1. That gives me a +1 equals x. So now out to the side, I have found my domain, which I'm going to write in green. Remember to put them in numerical order, starting with the smallest number. So 1, 4, and 6. And that's my domain. So you can do it finding the range and finding the domain based on what information they give to you. Alrighty. So they give us a function. I told you that eventually we would see our functions written as an equation. And you did get to see that up here. The equation was y equals 3x plus 2 and y equals -x plus 4. So in this case, we got to see the equation, we got to see the range, and then we got to see the domain. We did not see the table of values, and we did not see the graph. Okay? All right, now what we're going to see is the equation, and we're going to see the list of ordered pairs, x comma y. And let's see, this is the domain values, and this is the range values. This is the equation, and this is the ordered pairs. The only thing that we're missing here is the graph. All right. So let's go ahead, and what we're going to do is we are going to take the information that we know, the domain, and we're going to replace the domain in for the x into this equation. So I'm going to write y equals 2 parenthesis minus 4. Y equals 2 parenthesis minus 4. I'm going to just go ahead and do this all the way down to make it easier for myself. And now I'm ready to just go ahead and plug in each of my domain values. So -3, -1, 0, 1, and 2. So I have plugged them all in to where the x value went in the equation. Now what I have to do is to simplify this equation. So I'm going to kind of do some mental math. You don't have to write this down. I have 2 times negative 3, which is negative 6, and negative 6 minus 4 is negative 10. Let's do the next one. 2 times negative 1 is negative 2. Negative 2 minus 4 is negative 6. 2 times 0 is 0. 0 minus 4. 2 times 1 is 2. 2 minus 4. And then 2 times 2 is 4, and 4 minus 4. So I have found all of my range values. Now let's fill in the ordered pairs. So they have to look like this, and they will have commas, and I'm just going to fill in. So the domains were negative 3, negative 1, 0, 1, and 2. The range values that I found were negative 10, negative 6, negative 4, negative 2, and 0. And if you wanted to see the graph, you could then plot these ordered pairs and look at the graph. Perfect. Let's go ahead and get started with our number 4 here. I'm just going to go ahead. I see that they gave me the x values. So I'm just going to fill in my list here of all the equations. This is my domain. This is my range. So I'm going to take the domain of negative 6 and I'm going to plug it in right there. Now, if you need to do some scratch work off to the side where you do 2/3 times negative 6 over 1, you could say 2 times negative 6 is negative 12, 3 times 1 is 3, and then get your negative 4. And now that I have my scratch work out to the side, I do want to say, or just remind you, that there is this plus 2 afterwards. So we need to take this negative 4 and add 2. Negative 4 plus 2 is negative 2. And so then I'll put those together as an ordered pair. Negative 6 comma negative 2. And that's my ordered pair. Now I'm going to erase my scratch work because it was just scratch work. And I'll do another one. So 2/3, and I'm going to input negative 3. 2/3 times negative 3 over 1 will give me negative 6 over 3, which is negative 2. And then don't forget to add that 2. Negative 2 plus 2 is 0. So my y value is going to be 0. And then my ordered pair is the negative 3 that I input and the 0 that I got out. So I've done the first 2 in that example for you. I'd like for you to pause the video and try to fill in the last 3 output values, and then also give me what those 3 ordered pairs will be. So I have finished my table with all of my output values or my range, and then I have gotten my entire list of ordered pairs. And I am done with this problem. Just remember that you could always graph this and tell me if it's a function or not based on these ordered pairs. So far, everything in these notes has been complete review of those 3 lessons that I mentioned at the start of today's lesson. Now what we're going to do is add in 2 new examples that you've not seen. And this is identifying domain and range from a word problem. So let's read through number 1, and we are going to try to do this together. Joe has an after-school job at the local sporting goods store. He makes $6.50 an hour. He never works more than 20 hours in a week. The equation S of H equals 6.5h can be used to model this situation, where h represents the number of hours that Joe works in a week. And over to the right, it says create a table of possible hours and pay, and then answer what is the domain and what is the range. So what we're going to do is we're going to take what we know. That first we have this equation. All right. So I'm going to make my table. The S of H is actually going to be my Y values. My input values will be the hours. 6.5H, and then that's going to equal S of H. All right, and if you wanted to, you could put those together, and this would be your ordered pairs out here. Now, this is where it gets a little tricky because they didn't really tell you what numbers to input for your domain. So I do just want to remind us that our domain is H and our range is his total pay. So that's the range. So referring to the word problem, he never works more than 20 hours in a week. So that is going to be the maximum number of hours that he will ever work in a week. But what is the smallest number of hours that he could work in a week? Hopefully, some of you said 0. It is possible to take a whole week off, go on vacation, and not work at all. So the least amount of hours he can work is 0, and the most amount of hours that he can work is 20. So this is least, and this is greatest. And this is green. It represents our domain. So we can answer the very first question. What is the possible domain? 0 is the smallest, 20 is the largest. Now, the number of possible hours is anywhere from 0 to 20. So X represents all the possible hours he could work. I'm going to put that in the middle. And I'm going to use an inequality to represent all the possibilities for my domain. So X could be greater than or equal to 0 if you did a flip-flop on that. Or X could be less than or equal to 20. And that's how you represent your domain when it is all possible different representations. We don't want to go through and list every single one. Could you have put 0, 1, 2, 3, 4 all the way to 20? Yes, you could have. But what if he also works 2.75 hours in a week or 6.82 hours in a week? We don't want to have to list every single possibility. So we list this as a range of smallest to largest and anything in the middle. And that's how we write it. Now we've got to figure out the smallest possible salary he could earn and the largest possible salary he could earn. So S stands for salary. All right. So what I'm going to do is I'm going to take my input and I am going to plug it in and I'm going to simplify. What is 0 times 6.5? And the answer is 0. So I've got my smallest. Now let's do the greatest. 6.5 times the number of hours. So the greatest number would be 20 hours. So plug in 20. You can use your brain or you can use your calculator. And you would come up with $130 in a week would be his maximum pay. So this is the range, 0 to 130. He can earn $0 in a week or at most 130. Now, because we're talking about the range is the Y values, we're going to put the letter Y here. And it'll still be less than or equal to or greater than or equal to 0, less than or equal to 130. And that is how we write it. So this was my Y values. This was my X values. So my domain and my range, and that's how I answered the question. Let's do number 6 together. I'm going to kind of set up our table and get us started, and then I'm going to ask you to fill it in. All right? Andrea is selling candles as a fundraiser. She spent $50 on supplies for making 25 candles. She plans to sell the candles for $10 each. The function of her revenues is money that you earn, can be modeled by C of X equals 10x minus 50. So let's set up our table. All right, so I know that the function 10x minus 50 is going to go in here, but what is going to be representing my x values here? What does x actually mean? X is the number of candles. All right. And then my output would be her money, how much total she has earned. Okay. Or the cost, that she got back. So I want you to think about the domain. Okay. She spent $50 on supplies for making 25 candles. And I want you to take just a minute and think about what is the least number of candles that she could sell, or what is the greatest number of candles that she could sell, and then fill in your chart. So pause the video while you think about that. The most amount of candles she could sell is 25 because that's all that she made. She can't sell more than she has already made. The least number of candles she could sell is 0. What if nobody wants a candle right now? So then she would just have lost her $50. Now we're going to see how much money could she earn off of that. So fill in this and then input your domain. Fill in this and input your domain. So I'm going to give you just a minute to simplify those. Pause the video and go ahead and do that. So we've simplified 10 times 0 is 0. 0 minus 50 is negative 50. So she would have lost $50 and not earned anything, just the money that she spent on her supplies. And then if she sells all 25, 25 times 10 is 200. And then 200 minus 50 is $150. Great. So we have filled in our table. Now I want you to try to write for me what is the possible domain and what is the possible range. Pause the video and see if you can fill in the domain and range just like we did in example 5. All right, so I have filled in my domain, which I got. That domain represents the number of candles. She could sell greater than or equal to 0 or less than or equal to 25. That's the number of candles that she could sell. And that's my domain. The range is her possible earnings on these candles. She could possibly lose $50, so I would be greater than or equal to negative 50, or she could earn less than or equal to 150. And that's my range. So that's how we identify domain and range from a word problem. And we're going to get some more practice with that tonight on our homework. So let's go ahead, and if you have time to get started on that in class, go ahead and do that. And if we're about to run out of time, know that that's going to be your homework.